So we're looking at practice paper set 4, paper 3, the AQA calculator paper. Just having a run through of this test paper, just to give us a little bit of extra guidance on what we could have done right, having already tried this mock. So looking at question 1, we've got a multiplier question where we're trying to reduce a quantity by 12.5%. So multipliers are numbers which, if we multiply or times a number by it, so if we have a number, whatever that number is, just put a question mark for now, times it by, say, 1 or 1.00, your answer will always just be whatever number you started with, i.e. there will be no change, okay, no change, no increase, and no decrease. Okay, we're not going up or down, the number stays the same. If you want to multiply it by, if you want to increase that number, then what we need to do is multiply that number by a number more than 1. If we times it by a number less than 1, then we're going to decrease the number. Okay, so if we want to increase the number, we times it by a number more than 1. If we want to decrease a number, we times it by, multiply it by less than 1. And the percentage part, so if we want to think about the percentages, if we want to increase something by, say, 10%, so a 10% increase, then what we would multiply it by, our multiplier would be 1, like we've got here, 1 plus 10%. We're going to increase it by 10%. So 1 would keep it the same, but we don't want to keep it the same. We want to increase it, so we add 10%. 10% as a decimal is 0.1. We should know that from our knowledge that the number 1 is 100%, and therefore we can deduce that 0.1 is going to be 10%. And an extension from this is that 0.01 will be 1%. So if we have a multiplier that we were increasing, it needs to be more than 1. But if we want to say let's decrease by 10%, then what we're going to do is 1 on number we started with, which gives us no change, take away 10%. And as 10% is 0.1, it's going to be 1 minus 0.1, or 0.9. Okay, so our number here, if we were multiplying, if we were increasing by 10%, would have been 1.1, because we would have added 1 and 0.1. But if we're decreasing by 10%, then our multiplier would be 0.9. Okay, we're just playing around with that 10%. So if we want to reduce a quantity by 12.5%, we're going to multiply it by 1, take away 12.5%. 12.5%, if you know, remember what we said before, that 1% was 0.01, 10% was 0.1. An extension from this is that 0.1% would be another division by 10, 0.001. So if we're talking about 0.5%, it would be 0.1%, whatever that is, times by 5, so 0.005. Overall, you might be able to see that actually 12% is going to be 0. The 10 comes from 0.1, and the 2 comes from 0.02, so it's going to be 12% being 0.12, so 12.5% is 0.125. Okay, remember our half a percent here was 0.005, so therefore 12.5% is 0.125. 1 take away 0.125, which we could do in our column subtraction. However, this is a calculator paper, so if we put that into the calculator quite quickly, we would have got 0.875, which is why our answer is this one, 0.875. a little bit of indices laws for this one. So x to the power of 6 inside the brackets cubed outside. What this means is my x to the power of 6 is going to be multiplied by x to the power of 6, and then it's going to be multiplied by x to the power of 6. So when you cube something, you multiply it by itself and then itself again. So x6 is going to be multiplied by itself, x to 6, and then itself again, so x to 6. And if we remember our index laws, if we have x to the power of a times x to the power of b, then our answer is going to be x to the power of a plus b. So an extension to that is going to be, this is going to be x to the power of 6. As we're multiplying the same whole number here, we can just add the powers, x6, and then add 6 again, which is going to give us x to the power of 18. Okay, it's an extension of our index law that when the whole number is the same, we can, if we're multiplying these whole numbers, we can actually just add the powers, and that's going to give us the sum of the powers. So x to the power of 6 plus 6 plus 6, x to the power of 18, which is why this is our answer, x to the power of 18. The quadratic sequence for question 3. A quadratic sequence is a sequence which is going to have a squared term. So we're looking at something which is going to be a quadratic sequence which has either that at the start of my sequence. So if I was to work out maybe the nth term of some of these, then it might help. So the first one is going to be a linear sequence because we're adding 6 each time. So remembering deno, or the difference multiplied by n, plus the 0th term, or 0th term. So my difference here is going to be plus 6 each time, so the difference is 6n, plus the 0th term. Well, if I went back one in the sequence, then I'd be taking away 6, so it would be minus 4. So the nth term of the sequence is 6n plus minus 4, or 6n minus 4. Okay, so that is a linear sequence. And then I would go into looking at these sequences. However, for the sake of time on the video, let's just look straight at what the actual answer is. The quadratic sequence, if you think about n squared, the first term in that sequence would be 1 squared, the second term would be 2 squared, the third term would be 3 squared, fourth term would be 4 squared, so that's going to be 1, 4, 9, 16, which you can actually see is this one here. Looking at question 4, a bearing question, looking at the bearing of A from B. So what this means, A from B. So we're looking at starting at B and then we're going to A. So that bearing there, 235 degrees. Okay, remember bearings are always 3 digits, so if we were going, maybe let's call this C, so if we were going C from B, that may be something like 0, 8, 0. So that would be a bearing of 0, 8, 0, and then that's a degree, 0, 8, 0 degree. Always 3 digits and always measuring to the right, so measuring clockwise. With this question, if we're finding the bearing of B from A, then we're going A to B. So what is this bearing in that direction to there? And the way to think about this question is to imagine that we've got north drawn straight up here. So bearings will have north above a point. This point here was B, this point here was A. So we might have our direct north upwards. What this would mean is that we've now got two parallel lines. We've now got two parallel lines. If we extended this line down here, so it's a straight line through B from north, this would be 180 degrees because it is angles on a straight line. This angle here, though, is going to be very important. If we could work out what this angle is here, then what we've actually got is one of our parallel line theorems, or rules even. It's our alternate angles. If you can see here, I'm just trying to draw the alternate angles on there. If you turn it maybe sideways, you might be able to see that this is a reverse Z angle, or Zalternate angles, as I like to try and remember them as. And the Zalternate angles being equal. So the way of remembering it might be Zalternate, so you know it's a Z angle, so it looks like it might be a Z. Obviously it needs to be parallel lines, so we know that as both of these lines are pointing north, that they must be parallel. So it's a Z angle, but obviously you wouldn't write that, you'd write alternate angles being equal. Anyway, so we can work out what this angle here would be by doing 235, which is the whole of this angle, take away 180 because it's angles in a straight line. So that's going to give us 55 degrees. This angle here is 55 degrees. So a little column subtraction there to give us that. And as you know that alternate angles are equal, that means the angle inside there and inside here, as when you've got two parallel lines, the inside angles, so these two are equal. Well, if this is 55 degrees, then this angle here is 55 degrees, but as a bearing that would read 0.55. Question 5 is looking at a situation with speed given as a clue that we might be looking at speed, distance, time, so speed of the aircraft. The direct route between two airports A and B is 450 kilometers. An aircraft leaves at 9:15, it arrives at B at 10:55. So one of your first marks is given for telling me how long that was. So 9:15 to 10:55, so plus 1 hour, making it 10:15, and then plus 40 minutes. So it's plus 1 hour plus 40 minutes. So it's going to be 1 hour 40 minutes, or 1 dot dot 40. So 1 hour 40 minutes. If you want to work out the average speed of the aircraft, then it's going to be speed equals distance over time. And for these conversions, you are to the new to this syllabus is a few of these triangles. So there's always been speed is distance over time. So speed in your first triangle is distance over time. And there has actually always been density is mass over volume. So density is mass over volume. But this time we've also got pressure is force over area. So you need to remember these three triangles. This one is testing speed is distance over time. With that, you should know that if you wanted to work out, for example, distance here, if you cover it up and then it reveals as they're on the same level, it's distance equals speed times, so it's S-P-E-E-D, speed times time. Okay, this one, density is mass over volume, and pressure is force over area. So just bear in mind that although we are using speed as density over speed as distance over time, you do need to remember the other two as well, because there's a good chance that they will turn up in some which way. Looking at this question though, as speed is distance over time, the second mark was for attempting a distance divided by time calculation. Even if it was wrong, if it looked like it was your distance trying to divide by the time, then it will be giving you 1 mark. So the distance is 450 kilometers, and the time is 1 hour 40 minutes. 1 hour 40 minutes. And it is not 1.4. Okay, that was a big mistake that turned up quite a lot. Students thinking that it's going to be 1.4. It's not 1.4 because 100 minutes, which would be what is required to make one whole, if you were correct in thinking that 1.40 was the time. This is not true. 100 minutes is not one whole, it's actually 60 minutes. 60 minutes will give you one whole. Why? Because the whole is 1 hour. You're talking about time here. So as you're talking about time, you need to make sure that you're keeping your units correct. Speed is distance over time. So it's 450 over the time is 1 hour 40 minutes, but 40 minutes is 2/3 of an hour. So we can divide by 1 and 2/3. So 450 divided by 1 and 2/3, which would give us 270 kilometers per hour. Okay, this is how many hours it was. So our units are in hours, 1 and 2/3 hours, and our units at the top were kilometers. So it's 450 kilometers in 1 hour, 1 and 2/3 of an hour. So in your calculator, 450 divided by 1 and 2/3, 270. So if you had the aircraft not traveling the direct route, then what this means is that with your speed is distance over time calculation, if it doesn't travel the direct route, then the distance has increased. So if our distance has increased, but our time has stayed the same, so our time has stayed the same, because it turns out that the aircraft didn't travel the direct route, so it actually went further. It must have got an indirect route, so instead of going from let's say A to B, if we call this point here A and this point here B, instead of traveling in that direct route, it went an indirect route, so it could have gone like that. It's actually had to travel further. So the distance has increased, the time has stayed the same, because it hasn't said anything about the time changing. So the speed must have increased. We must have gone faster. And a reason for your answer is something about traveling further taking the same time so must be faster. Question 6 is looking at a percentage problem. It's got an element of rounding in it. So, to the nearest percentage, a survey of 1,000 motorists, and this is the driverless cars. 20% of them thought it was a good idea, 34% thought it was a bad idea, 45% weren't sure. Work out the largest possible number of motorists who thought driverless cars were a good idea. Well, 20% thought it was a good idea. This has been rounded to the nearest percentage, it's 1,000 motorists, and we want to work out the largest possible number of these motorists. So we're going to have to think about largest possible, nearest percentage, 20%. So 20% was got by rounding to the nearest percentage to get there. So 19.5% is the smallest number that if we rounded it to the nearest percentage would actually make 20%. Remember, it's the digit after the ones here because we're talking about nearest percentage being a whole percentage. So it's going to be in the tenths column. Is that a 5? Yes, it is. So it rounds up to a 20. On the flip side, what's the largest possible percentage? Well, 20.5%. For the same logic, 20.5% would actually round up to be 21%. So it can't have been 20.5% because that would round up to be 21%. So if we tried 20.4%, 20.4% would round to the nearest percentage to be 20%. So therefore, it must have been 20.4% to the nearest percentage, which would have made 20%. So we must have rounded 20.4% to give us 1,000 motorists. Okay, it could have been maybe 20.49% or 9 recurring percent or whatever to be that, but as we'll find later on, that's actually not going to be a whole motorist. So 20.4% is what we need to now find of 1,000. Okay, if we find 20.4% of 1,000, that should give us our answer. So if we deal with the number 100, so 100% is our whole number of motorists, our whole motorists, which is 1,000 motorists. Let's put motorists up here. So 100% is 1,000 motorists. So 10%, if we divide our 100 by 10 and we divide our 1,000 by 10, that will give us 100 motorists. If we divide that by 10 again, 10 divided by 10 will give us 1%. And if we divide that by 10 again, so 100 divided by 10, will give us 10. So 1% is 10 motorists. As we want 0.4%, we're going to want to know what maybe 0.1% is, because we can actually times that by 4 to give us 0.4%. So what we're going to do here is say, well, we've been carrying on this pattern, we've been shifting our digits to the right, and if we carry on doing that, we're actually going to get 1% divided by 10 to give us 0.1%. So 10 divided by 10 is 1. Now 20.4% is made up of 20% plus 0.4%. And if we know that 10% is 100, then 20% is going to be 200. Just double 10% to get 20%, so double 100 to get 200. And if we have 0.4%, and we know that 0.1% is 1, we times that by 4 to give us 0.4%, which is 1 times 4, which is 4. So 200 plus 4, 204. So our largest possible number of motorists is 204. Question 7 is a standard form question, and we're going to have to compare these numbers. So 9,812 to 9.82 times 10 to the power of 2 and 9.81 times 10 to the power of 3. First of all, 9,812 is the only number that is actually very easy to read because it's in a format that we're used to, 9,812. The other two are in standard form. So we're going to have to convert them into normal numbers, so numbers like this, for us to be able to read and therefore compare. It's also worth noting we're using the word ascending here. You've seen the word ascending used, for example, when we are talking about walking up a gradient. So usually when we talk about walking up a hill, we're ascending a hill if we're going from, in terms of land, from lower land to higher land. Okay, so we're ascending a hill if we're going from lower to higher land. in number world, that would be like saying going from lower numbers to higher numbers. So we want from smallest to biggest. So 9,812 is our first number. 9.82 times 10 to the power of 2. Well, 10 to the power of 2, anything squared, is itself multiplied by itself. So 10 to the squared is 10 times 10. 10 times 10 will give you 100. So if we think about, and it's useful if you have all our place value holders in the right place, so our 1s are going to be here, there would be a decimal point, and 0s infinitely here, but let's just keep it simple. So it would be 9.82. If we're timesing by 100, that means that our digits are all going to shift to the left by 2 places. Easy to visualize if you have put all your digits in the right placeholder values. So why they're jumping 2 places to the left? We're timesing by 100, 2 zeros, so we're moving 2 places to the left. Each digit as well is moving 2 places to the left, so the 8 is going to end up in this place, and the 2 is going to end up just in front of the decimal point. So if we write that down as a number, that would be 982, and our decimal point would be there. So next one is going to be 9.81 times 10 to the power of 3. 10 to the power of 3 is 10 times 10 times 10. So the little power, remember, tells us how many times the big number is multiplied by itself. So if we've got 10 to the power of 3, we've got 1, 2, 3 tens. 10 squared, or 10 times 10 was 100. So 10 times 10 times 10 is going to have another digit on the end, so another 0, sorry, and that would be 1,000. So we take the number 9.81, and we're going to move it to the left because it's getting bigger. We're multiplying by a number bigger than 1, and it's going to get to the left by 1, 2, 3 places. Three zeros, 3 places to the left. Again, same happens to the 8, and same happens to the 1. What we're going to end up with, and it's easy to, if I just write this again underneath, so it would be 9.81. There would be a 0 afterwards, and this 0 is going to be significant because it's moving 3 places to the left, and it actually ends up being in the 1's place. So 1, 2, 3 places, so it's going to end up 9, 1, 2, 3 places, so it's going to be 8, 3 places, so 1, and this 0 becomes important because it moves here to the 1's in front of the decimal place. Now, we have to say which one's the biggest, which one's the smallest, and therefore which one is actually in the middle. Comparing these numbers, if this is the number 982, it would have a 0 in front of it, and if we say first of all from left to right, the smallest number as we go from left to right indicates which number is going to be the smallest. So first of all, our thousands, 9, 9 and 0, so 982 is the smallest one. So 982 was 9.82 times 10 to the power of 2. So we'll write that one in there. That's our smallest. Now, we then have the other two. So we've got, they're both 9s in this place. They're actually both 8s in this place. So we carry on going in this process. They're both 1s in this place, so they're the same. Now in the 1s column, that's a 2, that's a 0. Therefore, 9,810 is smaller than 9,812. So it is going to be 9.81 times 10 to the power of 3. So this one that goes there. And by deduction, it must therefore be 9,812. That is the largest. Finally, looking at 7b, John is multiplying two numbers in standard form. You get 1 mark for ticking either one of these, actually, as long as you've got a statement that supports your answer. Okay, so you could actually be incorrect and tick the box that says correct, which is wrong. But as long as your working supports your answer, so your answer is correct. So here, down here, you're working, for example, I could have said A and C are 2 and 4 to give us me A, and then say, well, because it's 10 to the power of, if we use 10 to the power 6 or 10 to the power 7, 10 to the power 13, therefore he's correct. That would actually be worth 1 mark. To get the second mark, though, you must tick the correct box, and the correct box here is going to be not correct. So A and C, we need to provide a counterexample for. So we could pick anything as long as A and C multiply together to be more than 1. Because remember, standard form is a number between 1 and 9.9 times by 10 to the power of something. Okay, so it needs to be between 1 and 9.9. So if we say maybe that A was 6 and C is 7, then we would have 6 times, and let's use his powers, 6 times 10 to the power of 6 times 7 times 10 to the power of 7, and that's 6 times 7, which is 42, times by 10 to the power of 13. That is not in standard form because the number here is not between 1 and 9.9. To make it between 1 and 9.9, we would have to divide it by 10. Divided by 10, it would be 4.2. And to balance this out, we'd need to times the other part of our multiplication by 10. So it would be 4.2 times 10 to the power of 14. This works because if you think about 20 times 10, which is 200, if I altered 20 and 10, so if I said actually let's divide this by 10 to make it 20 divided by 10 to make it 2, but kept our 10 the same, then that number would actually be 10 times smaller, so it would be 20. To balance it with a multiplication, we have to do the opposite of what we did by multiplication or division to one part of our multiplication to the other. So if we divided by 10 here, we'd need to multiply this one by 10. So 10 times 10 is 100, and now it balances because 2 times 100 is 200. If we did 20 times 10 to give us 200, then we would have to divide 10 by 10 to give us 1, because 200 times 1 is 200. So you must do the opposite, and that's why this stuff is proving that this stuff always works. So we divide one part of our what we want to be in standard form by, say, 10, or if it was 0.42, we times it by 10. As long as we do the opposite to our power of 10, it will balance out. For question 8, we're looking at after the landing, an aircraft is delayed in reaching its parking stand. The aircraft uses 11.4 kilograms of fuel for each minute of the delay. 1 litre of fuel is 0.82 kilograms. Fuel costs 65 pence per litre. Work out the cost of the delay of 8 minutes. So we're looking at the cost of a delay of 8 minutes. First of all, with 11.4 kilograms of fuel for each minute of the delay. So we've kind of got a few conversions here. So we're going from litre and kilograms, and we've got this cost per litre in pence, and we're going to work out the cost of a delay of 8 minutes. Well, we've got to use a lot of multiplication, I guess, and division with a number solving problem, and then convert the units. So this is quite like a bit of a broad question in terms of what it's testing with your number skills. But first of all, think about the delay of 8 minutes and what that would be in terms of how many kilograms of fuel. Because if we work out how many kilograms of fuel that is, then we can actually convert it from kilograms then to litres at this point here. And then when we've got it in litres, we can actually find out the cost because we're given pence per litre. So first of all, we're going to do 8 minutes multiplied by 11.4 kilograms, which will give us the total mass of kilograms that will be lost, and that's actually going to be 91.2 kilograms. So 91.2 kilograms, if you get that, that is your first of the 4 marks. Then 91.2, as we're going to be putting it into litres, so we've got 91.2 kilograms, putting that into litres, we're going to divide, so share that into litres. 1 litre is 0.82, so we're actually going to do 91.2 divided by 0.82, and that would give us 111.2. You get a few more digits here, but let's just keep it as 111.2, and that'll be litres. Okay, if you wanted to store that number in your calculator, because you do get a few decimal places there, you can actually on your calculator, if I just do a little version of a Casio calculator, if you press Shift and then store it as one of the numbers or letters, sorry. So you could press Shift, store, then A. Now it should say A is whatever that number was. Now if you press alpha and then A, that number should come up. So 111.2 blah, 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 should be now coming up as A. That way you can actually save quite a lot of recurring decimals into your calculator and be much more exact with any calculations you do from there. So Shift, store A saves this number as A, whatever the last number was on your calculator screen, and then access it by pressing alpha then A, and that will give you the number that you stored as A. If you then press alpha A, which is your 111.2, as we're going to turn that from litres into cost in pence, multiply it by 0.65, and that will give you 72.29 roughly, and that is the cost. Notice a couple of things here. Firstly, your next mark was for getting 111.2. Your third mark was for trying that multiplication, and your fourth mark is for your answer. So you might have done alpha A times by 0.65 to get 72.29. If you got anything in the range of 72 to 72.3, so you could have rounded that, you will get that final mark. Importantly though, let's understand why we put 0.65. Well, our answer is looking in pounds. It's given us 65 pence. So in terms of pounds, 65 pence would be 0.65 pounds. So that would mean that we would need to convert it into pence. So 0.65 is how many pounds 65 pence actually is. That's why we times by 0.65. Question 9 is a question looking at a 3D Pythagoras at a glance, but we're actually saying the work out the formula, the length of the diagonal, is given as the square root of a squared plus b squared plus c squared. If you want to work out the length of the diagonal when a is 8, b is 3, and c is 2, give your answer to two significant figures. This is actually just going to be a substitution problem. So a lot of students end up trying to find this diagonal here. So if I just do that diagonal here, where it would be a squared plus b squared to give you, in Pythagoras, well, that would actually be c squared, but let's call it x squared, because that length has been given as c. And then try and do some weird Pythagoras, maybe here, and then end up here and getting the diagonal across there. You don't need to do any of that stuff. This is just a substitution question. A equals 8, b equals 3, c equals 2. So all you have to do is say, well, what is the square root of 8 squared plus 3 squared plus 2 squared? It says here a is 8, so just replace that a with the number 8. Likewise with b being 3, and likewise with c being 2. So square root of 8 squared is 64, 3 squared is 9, 2 squared is 4, add them all together, and you're going to get the square root of 77. And the square root of 77 is, top of my head, 8.77, I think so. 8.77. You would round to two significant figures. So first significant figure, second significant figure, third significant figure. So we only want two of them. The third significant figure was a 7. That would round this 7 up to an 8, so it would be 8.8. Okay, 8.8 is definitely the right answer. Mark-wise, you'll be getting 1 mark for substituting a couple of these numbers instead of the letters. Second mark for getting 8.77, or a number which, if you rounded to two significant figures, would be 8.8. And your third mark is for correctly rounding to these two significant figures that is specified. For part B, if I just write on the paper, you would be given, as above, it says a squared plus b squared plus c squared. So the square root of a squared plus b squared plus c squared is the length of the diagonal. So in terms of a, can we rewrite this? So we're not being asked to work out any exact values, we're just looking for an algebraic expression. And the clue that's given here for the substitution, which way you substitute, is it's actually given you b and c in terms of a. So what we have to do here is try and write all of these in terms of a. So a squared stays as a squared, b squared is going to be 2a squared. So by putting this in brackets, I'm remembering that I'm squaring everything here. A common mistake here would be to write 2a squared and then just leave it as that for later on. You're actually squaring, because it's b squared, so the whole of b squared, which is 2a. So it would be the whole of 2a squared. And the same with c squared, so it would be 2a squared. So we end up with a squared. 2a squared means, as you know, with squaring anything, it means whatever the term or number is multiplied by itself. So 2a squared, all squared, means 2a times by 2a. 2 times 2 is 4. A times a squared. So it's going to be 4a squared. And the same with the other 2a squared. Simplify that, as they all have the same endings. So not only do they end in a, but they have to end in a squared, and they all do. So we can collect the like terms. A squared plus a squared plus 4a squared plus 4a squared plus a squared, 4 plus 4 plus 1, 9a squared. So the square root of 9a squared, you might be able to recognize that is a square number. So the square root of 9 is 3. And the square root of a squared is a, because we're unwrapping that a squared. So it's going to be 3a. 3 marks, where they are. The first mark is for attempting 2a times 2a and getting 4a squared. Or just an attempt of 2a times 2a gives you 1 mark. The second mark was for getting all the way down here and getting 9a squared. And the third mark is for correctly square rooting all that, which would give you 3a. Question 10 is testing your understanding of the indices rules. So we have 4 squared plus 4 squared times 4 squared times 4 squared. And Eva thinks that this means 4 to the power of 2 times 2 times 2, which is 4 to the power of 8. So we have to understand really the difference between 4 squared cubed and when you have 4 times, so 4 squared times 4 squared times 4 squared. And for these, they are actually exactly the same. 4 squared means, all cubed means 4 to the power of 2 multiplied by itself and then itself again. So 4 squared times 4 squared times 4 squared. Now, when you have 4 squared times 4 squared times 4 squared, this is when you add your powers. So if it's written like this and you've got the same base number, which is 4, or it could be an algebraic term, so it could be a squared times a squared times a squared. That would work exactly the same way. This is when you would do 4 to the power of 2 plus 2 plus 2, which would be 4 to the power of 6. Okay. What Eva's getting confused about is her power rule here. So 4 squared all cubed is when it's 4 to the 2 times by 3, which will give you 4 to the power of 6, which is exactly the same as you should know by doing 4 squared times 4 squared times 4 squared. But she's not writing that. She's writing it like this. So she's written 4 squared times 4 squared times 4 squared, so like this. And what she's done is the classic mistake of multiplying the powers. So rather incorrectly, she's done 4 to the power of 2 times 2 times 2. Okay, that would be correct if we were doing 4 squared to the power of 4. That is when we multiply the powers. But here, we're wrong. We need to add the powers. So give the correct answer. Well, the correct answer is here, 4 to the power of 6. She should have added the powers, and a lot of people do just right. Should have added powers. But remember, for this new GCSE, when it says give the correct answer, we don't want to write it, we want to show it with the maths. Okay, so they're quite hot in the new GCSE on students showing how it should have happened with the maths. So again, not really providing a counterexample, but providing the correct example. So 1 mark, as this is 2 marks here, as I've done most of that in orange, I'll do this in green. So the correct answer, the marks were given out for, first of all, getting the right answer, so 4 to the power of 6, and secondly, for showing that it's 2 plus 2 plus 2 instead of 2 times 2 times 2. Question 11 is looking at a circle problem, so we're looking at arcs, and we're talking specifically about how much longer is the big arc than the small arc. So view this problem like this. We've got this big arc here, and if we want to know how much longer it is, then we're going to have to say, well, that big arc minus this small arc. So we're going to need to know how to calculate the arc length. And for the arc length, it's going to be, if you think about what an arc actually is, so if I try and continue that big arc here into a full circle, the arc is just a part of the circumference. So the circumference would be the whole circle, an arc is a part of that. So therefore, knowing how to calculate the circumference of a full circle is going to be important. So the circumference of a full circle is given by pi times diameter, or pi times 2 times radius. Okay, so 2 radius make up diameter. Remember your parts of a circle, that's the radius, and that's the center to the circumference, and 2 of them next to each other make up a diameter. So 2 radii make up a whole diameter. So as we're given the radius here, it's probably going to be more sensible to use our radius formula version. So the circumference, which I'll just put as C, is pi times 2 times r. You might see it as 2 times pi times r, but it doesn't matter with the laws of multiplication. It doesn't matter if it's, for example, 2 times 3 or 3 times 2, the answer is still going to be the same. In that case, there'll still be 6. It doesn't matter if it's 2 times pi times r or pi times 2 times r. Okay? So our radius is going to be, for the big circle, 5. 4 plus the 1 to give us 5. Okay, it's worth noting also, if we're looking at how much longer the big arc is than the small arc, then what we're actually going to do is the big arc, find out what that is, and subtract the smaller arc. That will give us the difference, i.e. how much longer. So the radius is 5 for the big arc, so let's put B over here for the big arc. So it's going to be pi times 2 times 5. And for the smaller arc, let's do it down here, smaller arc, circumference, same formula, so it'll be pi times 2 times, for the smaller arc, as it only goes up as a radius of 4, it's going to be that. So incredibly, that's actually going to be 2 marks. Our first mark was for getting one of these formulae written down, and the second mark is for getting the other formula down. Sorry, I should have added actually the, as long as you've got that, you do actually need to put how much of the circumference is there as well. So pi times 2 times 5 is going to give us the circumference of the whole circle for the big arc, so this part. But we don't want all of that. In fact, we only want a fraction of that. We only want, out of the full circle, which would be 360 degrees, we actually only want 120 degrees of that. So we're going to multiply by 120 over 360, because we want 120 out of 360 of it, 120 degrees out of the full 360 degrees. So if we've written that formula down, that's your 1 mark. And then writing that as it's the same degree as well for the smaller arc, it's going to be times by 120 over 360 as well. That's worth 2 marks. So the first mark for writing one of these two, and the second mark for writing both of these two. Okay, just to recap very quickly again, we're doing the circumference of the full circle, but then we only want 120 degrees of that, which is why we times it by 120 out of 360. Same with our small arc. If we calculate what they are, so for the big one over here, it will be 10.5 centimeters. So we've got 10.5 centimeters for that one. Calculating this one will give us 8.4 centimeters. And if you want the difference, so we want to do the big arc, subtract the small arc. So 10.5 minus our smaller arc, which was 8.4. That's your third mark for any attempt to subtract. So showing an understanding that you're finding how much longer it is by subtracting is the third mark. And the fourth mark is for writing the answer. 10.5 minus 8.4, 2.1 centimeters. So that's your fourth mark. And that is the arc question completed. So worth knowing your circumference of a circle formula, and then remembering that if you want part of the full circle, just work out how many degrees it is out of 360, the full circle, and multiply by that angle over 360. So I think it's important to understand when we ask you to solve simultaneous equations what that actually is. So understanding is obviously going to be a very important part of developing your math skills. And when we've got these two equations here, when we're asking to solve simultaneous equations, a lot of students are very keen to straight away try and eliminate variables or substitute into one equation to the other. But to understand what we're actually doing when we're solving simultaneous equations, it's easier to understand if I guess we draw some a set of axes. So I've got my y-axis and my x-axis here, and I've got these two linear equations. We know they're linear because there's no squared terms anywhere, or we know they're now cubic because there's no cube terms anywhere. No fractions to say reciprocal or anything like that. So we could rearrange them to be in the form y equals mx plus c, and roughly we would have something that looks, emphasis on the roughly, something that looks a little bit like this, where our second equation is here, so this is our 3x minus y equals 13, and over here will be our 3x equals, so 3x plus 2y equals 10. So it looks something like this. And when we solve this simultaneous equation, what we're actually trying to find is the x value and the y value, where they both cross. So we're trying to find, well, what is this x value and what is this y value here? Well, if we go straight across, we'd be here. So what that means is for both of these lines, at this point here, they're going to have exactly the same x value and exactly the same y value. Those are the solutions to these two equations. If we extend it to maybe a quadratic example, so if I have a little sketch over here, there's a limit to how rough we can be here. So if we have a set of quadratic graphs, so if I have one quadratic which looks something like this, and then a straight line that looks something like this, we might be in a situation where there are actually 2 points at which they cross. Okay, so we get that one there and that one there. So we want to know the x values and the y values for both of these. In this case, you'd get, for example, x and y, and then another x and y. So you'd have to find both sets of coordinates, because these are going to be two very different points. Okay, there may be a case where if you've got a quadratic, it would only touch at one point, but more often than not it will go through. This would have to be where the quadratic has a tangent. Question 12, we're looking at solving the simultaneous equations 3x plus 2y equals 10 and 3x minus y equals 13. So to solve this, first of all, isn't going to be too hard because we've got the same number of x's actually already given to us. So what I want to actually do here is explain what actually happens when we're solving simultaneous equations. A lot of the time we kind of do this without actually trying to understand what it is that we're actually doing. So if we were to rearrange 3x plus 2y equals 10, it would look something like this. It would be a straight line. Obviously not with any of these kinks, it would just be a straight line straight down, and 3x minus y equals 13 would actually be a line looking a little bit more something like that. So that would be our 3x minus y equals 13, and our 3x plus 2y equals 10 would be something like that. And when we're solving simultaneous equations, what we're actually doing is finding that point at which they cross. Okay, if it's a quadratic, so if we just sketch, if it was a quadratic, we'd have something like that, and there may be a straight line going through it, in which case we'd expect to find two of these crossover points. But generally, with two straight lines, we'll find one crossover point, and more often than not, we'll have two crossing points for a quadratic, unless it hits at a tangent, a straight line which is a tangent, so it might only cross, for example, there, just one point. So we're actually finding the point at which the x values and the y values for both of these lines, or these lines, are the same, because where the x values and the y values are the same is going to be one of our crossover points. So solving these is finding the x and y values at which this crossing point happens. So anyway, to solve these is actually not going to be as hard as needing to understand all of that stuff. If it was graphical solving, then it would be useful to know that. But for this equation and this equation here, to solve it, first of all, you could try substitution. However, as you've already got 3x and 3x here, it's going to be easiest if we just try and eliminate. And when we eliminate, it means we're trying to get rid of one of the variables. Both of these equations have two variables. They're x and y. X and y. If we try and get rid of either the x's from both equations, or get rid of the y's, we'll be left with only one variable. And when you have one variable in an equation, for example, 3x equals 9, it's quite relatively simple to actually see that x is going to be 3, because we divide by 3 on both sides. However, it's a lot harder if you have two variables. So, long story short, if we're going to try and eliminate these variables, we have to make sure that they have the same number of either x's or y's. As we've got 3x here and 3x in the other equation, we can subtract. 3x minus 3x will give us 0. If we're subtracting one equation from the other, we have to do that for every other value. So I'm doing these lines, which I'm actually trying to signify means subtract. Okay, so these are meaning subtract, so equals subtract. So 3x minus 3x is 0, 2y minus y, so 2y minus y equals 3y. So I'll make it a little bit bigger. 3y. Remember, when a minus and a minus are next to each other, it means it's a positive. So 2y add y makes 3y. And then our equal sign, 10 minus 13 is going to be minus 3. So we now have 0 plus that was plus 3y equals minus 3, so therefore 3y equals minus 3. So we divide by 3 on both sides. As our number attached to the letter is 3, so 3 divided by 3 would be 1, 1y equals minus 3 divided by 3 is going to be minus 1. If you think about positive 3, if this was positive 3, it would be 3 divided by 3, which would be 1. But as it's minus 3 divided by 3, it's going to be minus 1. And remember also that instead of saying 1y, we always just say y. So y equals minus 1. When y equals minus 1, the x values and the y values are going to be the same, so we've got one of our equations. It doesn't matter if we took this equation or our first equation. It doesn't matter which one we take. I'm just going to take the second equation. I know that y equals minus 1, so let's just write the whole thing here. 3x minus y equals 13. And if I know y is minus 1, I substitute it in. Let's go for blue. 3x minus, and then minus 1, because it's subtract 1. So that's going to equal 13. Minus and minus makes a plus, remember. So I'm writing out this in full. You could skip a few steps if you want, but I don't want to miss anything here for the understanding. So 3x plus 1 equals 13. So I'm going to eliminate the plus 1 by taking away 1, so subtract 1 on both sides. So 3x equals 12, and hopefully now you can see you divide by 3. So x equals 12 divided by 3, 4. So x is, and let's just put it in the same colour so we're consistent, x equals 4, y equals minus 1. The breakdown of the marks for this one, 3 marks. 1 was for eliminating, so over here when we eliminated our x's, that was 1 mark for that. The second mark was for getting either 4 as x or y as minus 1. So this would be the second mark for getting one of these, and then the third mark for getting another one. So actually, if we were to resketch this, we know that they would cross at x is 4, y is minus 1. So our crossing point would be actually over here. And again, let's try that again. So it would be on our coordinate axis, x is 4, y is minus 1, so it looks something like that. That would be the crossover point. Question 13 is an understanding of your formula question. So this is not a very good question in that it has very little actual benefit to you outside do you know the formula. So this is unfortunately one of the parts of the new scheme of work which is going to be tested, is knowledge of retention of formula. So it's very rote. You kind of have to know the formula for compound interest, and I'm not going to spend too long on it. It's going to be that one. P is the principal amount, so our value at the start before any interest is applied. So principal amount just meaning value at the start before anything's been applied. R being the interest rate, which is a percentage, so it's out of 100, and then it's raised to the power of the number of years. So there's 1 mark for that, and I don't really want to spend too much time on it. Question 14 though, rearranging the formula v squared equals u squared plus 2as, plus 2as, make s the subject. So when we're rearranging a formula to make one of our letters the subject, what we're going to end up with is s equals and then an expression of sorts. This makes up the whole equation, but to get there, we're going to see this as 2as needing to be, as it's the only thing with s in it, out of these 3 terms, so 1, 2, 3 terms here, s is only appearing here. So we need to isolate, we need to make this term on its own on one side. So if we see these as 2 sides of the equation, then to make s the subject, we need to think about getting rid of anything on the same side as the term with s in it. Okay, so we need to get rid of anything on the same side as the term with s in it. So v squared can stay on this side over here, but we need to get rid of u squared, okay, because that's the other term with our 2as, which contains our s. So how are we going to do that? Well, how do we get rid of u squared, i.e. make it into 0? We're going to subtract u squared. So if you subtract u squared on both sides, that's going to mean on this side we've got v squared minus u squared, and on the other side we're going to have u squared minus u squared, which makes 0, and so we're just going to actually have 2as. So v squared minus u squared equals 2as. Now we're going to need to, in one step we can do this, make s the subject, so get it by itself. This is usually done when we've got something like 3a equals, I'll try and pick a different example, 18. So if you've got 3a equals 18, hopefully you can see it's actually not too hard. We're going to divide by 3 on both sides to give us a by itself, or usually 1a, so 3 divided by 3 would be 1, but we don't write that. So it's going to be a by itself equals 18 divided by 3, 6. In principle, we're actually just doing the same kind of thing here. So we've got to get s by itself. So we're going to divide both sides by 2a. That's the term that's with s, and we want to get s by itself. When we had this example here, we had a 3 with the a. We wanted to get the a by itself, so we divided by what was attached to it, which was the 3. So here we're going to divide by 2a. 2as divided by 2a, so it's meant to be an a there. 2a divided by 2a is going to be 1, but 1s, which we just call s. And on the other side, we're going to have v squared minus u squared, but we're dividing the whole thing by 2a. So it's going to be v squared minus u squared, all divided by 2a. Okay, so when we're dividing an expression with 2 terms by something, we can actually just write a line over it and then 2a underneath. Okay, so you can underline it and then just write 2a underneath. This means v squared minus u squared all divided by 2a. And that's actually going to be our answer. V squared minus u squared divided by 2a equals s. So a couple of things. It is 2 marks, and our first mark is actually for what we did over here, for rearranging to get v squared minus u squared equals 2as. That was worth 1 mark. Our second mark was for writing this completely. And when I say completely, I mean if you put v squared minus u squared over 2a, you would not get the second mark. The answer here hasn't said s equals and then left it blank. It's just said answer. So you need to be very specific. This would not get the marks. You need to say equals s. Question 15 is an iteration question, working out an approximate solution to x cubed plus 3x minus 1 equals 0. Use the iteration x subscript n plus 1 equals 1 over x subscript n all squared plus 3. Start with x subscript 1 equals 1. Give your answer to do the 2 decimal places. Right, so this is new to the GCSE, iteration, and sometimes you'll have a warm-up question which will say something about rearranging this to make it something like this. I'm not going to talk about how we do that for the sake of efficiency, but how we'd answer this question is very important, because we can either say, we can make it very easy for ourselves, or we can kind of slog through rewriting this equation again and again. So what we're going to do first of all is grab our calculators, and as it wants us to start with x subscript 1 equals 1, what we're going to do first of all is say, type on your calculator just the number 1 and then press equals. If you press 1 and then equals, it will store this as the answer. So A and S. If you now press A and S, you'll see it equals 1. So turn off your calculator, turn it on again, press equals, or sorry, press A and S, and you'll find that it's 1. So that's very important because we can rewrite this. So what this means is the next number in the iteration, the next number, so n plus 1, is 1 over the previous number squared plus 3. So the next number is 1 over the previous number squared plus 3. That's all we mean by subscript n and subscript n plus 1. Subscript n is the number, which we're given actually here, x to the 1 equals 1. So we're saying, well, x to the n plus 1, which would be x to the 2, because our n was 1, therefore n plus 1 is 2, is going to be 1 over this squared plus 3. If you type into your calculator, so press your fraction button, which looks something like this, so worth definitely knowing where that is on your calculator. If you type that in and then at the top put a number 1 and then over it write A and S, so press A and S, square it, so A and S squared plus 3. Okay, if you've made A and S come up as the number 1 in this case, because that's what x to the 1 was, then all you have to do now is press equals. If you press equals, you should find that it is 0.25. If you press equals again, then as A and S is now stored as 0.25, your next number, if you just press equals, it will give you the next iteration. You don't have to type in the whole equation all over again with 0.25 as the previous number. So we don't have to put 1 over 0.25 squared plus 3. You can just press equals. Eventually, that will give you the numbers 0.3218 and 0.3222. Make sure that however far you go, x4, x5, that you're writing each number that turns up. All you have to do is press equals and it gives you the number. And eventually you'll see that to 2 decimal places, if we were to round these numbers, they would actually be 0.32. Okay. This is a 0.3218, this is 0.322. Both of these numbers, if you rounded them to 2 decimal places, would be 0.32. Where you notice that first change, so that first change in that, if you rounded this number to 2 decimal places, it would be 0.32. If you rounded this number to 2 decimal places, it would be 0.32. Then that is your answer. If we rounded this to 2 decimal places, I mean it is already to 2 decimal places, so it would be 0.25. You see that it changes, and where you see the first change of number which keeps the 2 decimal places rounded to the same thing, that will give you the answer. Okay, so if I had another example which was 0.376 and then 0.374 and then 0.371, I would have carried on until I found that if I rounded my numbers to 2 decimal places, they stayed the same. So this to 2 decimal places was 0.38, this to 2 decimal places is 0.37, and this to 2 decimal places is 0.37. As we've got the same number to 2 decimal places, when we've done the next iteration, that tells us that this is the answer. Okay, so that's what I mean by to 2 decimal places, so carry on until you see that to rounding your number that you get to 2 decimal places, you've got the same thing. Okay, so 3 marks. The first mark is for getting 0.25, so iterating first of all, the first time will give you 0.25, which is your first mark. Your second mark was for getting either one of these two, so 0.3218 or 0.322. And your third mark is for correctly finding what it is to 2 decimal places, which is 0.32. Right, so we've got a question which is about circle theorems. Here is a circle, centre O, and if you've learned your circle theorems, hopefully this won't be too hard. So this is the one which people do sometimes get confused with because it looks like it's just, oh, that's that one with the arrowhead. Just be careful, because if this is centre O, there is a version of this where they give you an arc like this, and they might actually say something like that, and they'll say, what is this angle here? Given that this angle, for example, let's say this angle is 20 degrees, this is the same rule as this. Even though this looks like a nice delta, this is actually the same rule. If the angles are subtending, so coming from the same arc, so this is your arc here, if they're subtending from the same arc, then the angle at the circumference, so the angle here, is half of the angle at the centre, more commonly known as the centre. Angle at the centre is twice the angle at circumference. So the angle at the centre is twice the angle at circumference. If this is 52 degrees, then 2 times 52, 104. Okay, so that's your rule. But just be careful, because they have in the past thrown the question something like this. It's all about subtending from the same arc. So as it's come from this arc, these two angles, the angle at the centre is twice the angle at circumference. So if I, for example, was to draw it out here like this, that angle here is 52 as well. It must be 52 because it's subtended from the same angle. And the angle at the centre here, x, is still 104. So they could have drawn it like this, so be careful. (16b) M, N, and S points at circle C1. RST is tangent to C1. Circle C2 passes through the centre O. S and M of circle C1. So it looks a bit messy, but let's just try and understand what's going on here with, first of all, RST, this straight line here. RST is a tangent to circle C1, so C1 over here. If this is a tangent and this is the centre, we can actually draw, and I'm going to try and be really careful here, we can actually draw a radius there, which is going to be useful because we know that the angle, well, you should know that one of our circle theorems is the angle between a tangent and radius is 90 degrees. And yes, we do have to say this because it says please, it doesn't say please, I wish it did. It says give reasons for your answers. So angle between the tangent and the radius is 90 degrees, therefore this angle is 90 degrees. Okay, and if this angle is 90 degrees, then you can actually work out what angle MSO is. So angle MSO is going to be 90, because we know the whole thing here was 90, but I'm going to avoid drawing on it to try and save some space, is 90 minus 48. And 90 subtract 48 is going to give us 52, is going to give us 42 degrees. Okay, so this angle here, therefore we can actually say that OSM or MSO, same thing, OSM is 42 degrees. Okay, so that is a useful start and would actually give you your first mark. After that, what you can say though, if you know that this angle here is 42 degrees, I'm just going to try and do an arrow over there because I want to keep this as tidy as possible for you. So that is 42 degrees. What you can actually do now is at M and O, you can make another radius here. So that's going to be a radius. Why this is important to do is because what we've now created is a triangle here where we know this is the radius of that circle and this is a radius of the same circle. So this is actually, if I try and do straight lines for it, is actually an isosceles triangle. And what we should know about isosceles triangles is that the angle which is in between the two sides, which is the same, is the angle which is different. Two of these angles must be the same. And the angles which are the same are the two which are not enclosed by the sides which are the same. So this side is a radius, this side is a radius, so this is the angle which is different. Therefore we know that OMS is also 42 degrees. So another rule we've got here is isosceles triangle, and you don't have to write much more than that really. Therefore, OMS is also 42 degrees. What does that mean? Well, that means that angle, if this is 42 degrees, this is 42 degrees, angles in a triangle add up to 180, so 180 minus 42 minus 42 is going to give us 96 degrees. So that tells us that this angle here, MOS or SOM, is going to be 96 degrees. So let's try and do it in red pen here. That angle there is going to be, so SOM is 96 degrees. So angle SOM is an angle which is actually inside a semicircle. So as this is an angle inside a semicircle, and it is not 90 degrees, so you should know that angles in a semicircle, an angle in a semicircle, one must be 90 degrees, and it is SOM is 96 degrees, and 42 degrees here and 42 degrees here, so it is not actually going to be a diameter. So S to M is not a diameter, okay? Because if it was a diameter, if this was a diameter, then this angle created would have been, as it's inside a semicircle, 90 degrees. It is not. We've showed that it must be 96 degrees, so therefore SM is not a diameter. Just for a little bit more clarity though, so let's just try and remember what we've got here. So angle SOM is 96 degrees, right? So let's get rid of it. Prove that SM is not a diameter of circle C2. So here's C2. If S and M is a diameter, then the angle created in a semicircle to the circumference, this angle would have to be 90 degrees. Okay, one of our circle theorems states that if you've got a diameter and an angle created to the circumference, that must be 90 degrees. Wherever it is, it must be 90 degrees. So I've just done a few examples here, but the point is that that diameter there and that point on the circumference is inside a semicircle, therefore this must be 90 degrees. If this is the diameter of circle C2, then this angle here must be 90 degrees. But we showed that it is actually, due to using our isosceles triangles, working out these two angles, we showed that it was 96 degrees and not 90 degrees. So for clarity, hopefully that makes this question a little bit more clear. But it's obviously a very kind of confusing question because we've got two circles that are overlapping and then we're making isosceles triangles. A general rule of thumb is if you've got a center of a circle given to you and a tangent, that's a clue to start using maybe a radius. And if you've got these points on the circumference, start thinking about maybe I can use the radius to help with the definition here. A question now on some of the compound measures which are less common but more much more frequent actually in the new GCSE. So there are a few extra equations that you're expected to know rather than just speed is distance over time. You actually have a few others, so only a couple others. So your other two compound measures which are important to remember are pressure and density. And density clearly is going to be the one useful for here, but it's worth trying now to kind of think, what are they? Well, pressure is force over area, and density is mass over volume. So however you can try and remember these, it's worth just memorizing a couple of extra triangles, because they do turn up and they will turn up in some way. I think I haven't really seen many force, pressure and area questions, so I reckon that might be one that's worth trying to practice a little bit more, because you see density quite often. So it might be turn for the force, pressure, area. Pressure is force of area. So with this problem, we've given the density of steel generically is between these 2 kilograms per meters cubed. We know that 1,000 kilograms per meters cubed is 1 grams per centimeter cubed. A solid metal object has a volume of this, so we want to know if our solid metal object is made of steel. Is it definitely? It might be, or it's definitely not. The mass of the object is 9.6 kilograms. So, density is mass over volume. We know the volume is here, but it's in centimeters cubed. So the density is the mass over 1,430 centimeters cubed. We need to first of all say what the mass is in terms of centimeters cubed. We need the units to be the same. Okay, so we've got kilograms here. We know that 1,000 kilograms is 1 gram. 1,000 kilograms per meter cubed is 1 gram per centimeter cubed. If we're given 9.6 kilograms, well, that's going to be 9.6 times 1,000. So to go from 1 gram to 9.6 grams, we times by 9.6. To go from 1,000 kilograms, we're going to times by 9.6, and that is going to give us 9,600, and now we're in grams per centimeter cubed. Okay. Now, as our units are the same, we're both dealing about centimeters cubed here, we can divide and know that our units are going to be correct. So let's divide these two. 9,600 divided by 1,430 is going to give us roughly, so the density of 6.713. Okay, so our density is going to be roughly 6.713, and that is in grams per centimeters cubed. Okay, so what is that? I mean, we've got grams per centimeters cubed here, but up here we've been given the densities which are between these two values, but it's in kilograms per meter cubed. So we're going to have to say, okay, well, that's the density of our material, our metal object here. We've worked that out. But is it steel? Well, if we divide this by 1,000, because we know 1,000 kilograms per meter cubed is this conversion here, so divided by 1,000, and that's going to be 7.750 grams per centimeter cubed. So from there, as this is the lower bound, then this value is lower than 7.750. It's actually definitely not going to be steel. And the breakdown of the marks here, if I just show you there's 3 marks. The breakdown of the marks here are, for just writing 9,600, that's 1 mark. So all you have to do is say, well, that's that in kilograms, so that's going to be 9,600 grams. The second mark is for actually dividing the correct units here. So 9,600 divided by 1,430. So as long as you've made an attempt at a division where they're either both in kilograms or both in centimeters, grams per centimeters, then it's absolutely fine. And then the final mark was for having a value, it could have been 6.7, that would have been fine, and ticking, definitely not steel. So that's the third mark. Question 18 is a comparison of the mean and interquartile range of plants that have been treated with plant food. So we've got comparing the treated and untreated. So we've got the untreated first of all, and we've got to say what do these numbers actually mean. So we're looking at higher order kind of comparison of what treated and untreated actually means? Well, as they've given us the mean and interquartile range, well, let's compare the means and let's compare the interquartile range. Okay, always write interquartile range, don't just write IQR. And what we're going to say is that the mean for treated plants are taller. So the mean is bigger for treated plants. That will get you no marks. What you need to say is this means that treated plants grow taller on average. Okay, so that's what we mean by interpretation. So comparing them, we're needing to say, well, the mean is bigger for treated plants, but what that actually means is we're talking about height here. So if their mean is taller, if the mean is a larger number, that means they're growing taller. Say that. That's worth the mark. Interquartile range. Well, the interquartile range for untreated plants is bigger or larger, just to be different. What this means, well, this means that there is less variation in treated plants. Don't forget the interquartile range is talking about the spread of the middle 50%. So we've got, if you imagine very sketchily, a box plot would look something like that. The values between here and here, which is your interquartile range, this is where 50% of the data lies. Okay, so we're saying if this box is bigger, then they're spread more. So the variation is larger if it's a larger interquartile range. What this means is if it's smaller, that there is less variation. So, for example, if I do it in a different color, our treated plants might, if we're talking about the same higher and lower value, might have an interquartile range which is something like this. So it might be something inside there. So this means that there is less spread out data, meaning that there is less variation in treated plants, and what I should probably say is heights here. So there is less variation in treated plants' heights. So 1 mark for each comparison, but you don't get anything if you aren't actually interpreting it beyond the superficial mean is bigger, interquartile range is bigger. Okay, so we need to say what that actually means about what this guy's talking about here. Question 19, furthermore, box plots. It's quite hard to see this one actually, but the value of the range, first of all, which is the largest number minus the smallest number. So the highest value here is 80. So the highest value is 80. The lowest value is 30. So the range is the difference between the largest value and the smallest value, which will be 50. The median in a box plot is it'll be a lot easier if we shade this in a bit. So here's our box plot with the box that I've tried to do in yellow. Our median is the line here. So this line was in the middle of the box plot, somewhere, sorry, not in the middle necessarily at all, but it was a line which was inside our box. That line inside our box here is the median. And so we read this down here as we're jumping 60, it's got 1, 2, 3, 4, and then we're at 70. So there's 5 gaps here. That means we're jumping in 2s. So 62, 64. And that trick is why they've kind of put 62 and 64, because it's just saying, do you know the difference between these gaps? Well, yes, they're going to be 2 each. So that's 62 here, 64 there. so 64. Circle the value of the interquartile range. The interquartile range, as we talked about on the previous slide, was the difference between the box. So this is our upper quartile, this is our lower quartile. Reading off, that's going to be 74. So the upper quartile is 74, the lower quartile is 38. So we can do 74 subtract 38, and I'll just show you how we do it if we did the column subtraction method, if you were wanting clarity on it. So 14, so we've taken one of those 10s off to make it 6, and then we put the 10s here, so it's going to be 14 minus 8, which is going to be 6, and then 6 subtract 3, which is going to be 3. So that's going to be 36. So the value of the interquartile range is going to be 36. Question 20 is looking at a knife is twice the cost of a spoon. 8 spoons and 12 knives cost £46 and 8 pence. Work out the cost of one knife. It looks a lot more confusing than it actually is. For these kind of questions, first of all, don't freak out. It looks like it's really arbitrary, but what you need to do is take each sentence and try and see what you can kind of create from it. In terms of algebra, we can say a knife is twice the cost of a spoon. So straight away from that, a knife, let's just call it K, is twice the cost of a spoon, so 2s. Okay, so K equals 2s. That's what we can get from that. We can also say from the second sentence, 8 spoons and 12 knives, 8 spoons and 12 knives cost £46 and 8 pence. So 8 spoons plus 12 knives cost £46 and 8 pence. I'm just going to ignore that pound sign for a second and just keep it simple with that. So if K equals 2s, and we know 8s plus 12k equals £46 and 8 pence, we can actually, this is a simultaneous equation, we can substitute. If we know that k equals 2s, we can replace that k with what we've known it to be from the first equation, which was 2s. So instead of writing 8s plus 12k equals £46 and 8 pence, we can actually write 8s plus, and for trying to see the calculation a bit clearly, I'm just going to put a bracket around it. 12 times, instead of k, we know it's 2s. So 12 times 2s, close bracket, equals £46 and 8 pence. So now we've got s's, so let's try and simplify this a bit more. 12 times 2s is going to be 24s. So we've got 8s plus 24s, which will be 32s. So 32s equals £46 and 8 pence. So what we can do now is divide by 32 on both sides. And so we get s. 32 divided by 32 is 1, but remember that's 1s. So s equals £46 and 8 pence divided by 32. And that's going to give us £1, so £1 and 44 pence. So if we know s is £1.44, if we know that k equals 2 lots of s, then we just double this. So k is going to be £2 and 88 pence. So there are other ways of doing this. You could have, for instance, at this point here, said, well, if k equals 2s, I'm looking for k, so why don't we just say, well, this is going to be 4k instead of it being 8s. Let's say that, divide that by 2, and that's going to give us the number of k, and therefore you'd have solved it slightly differently, but ended up with the same answer, which is £2.88. But this is 5 marks, and you get 1 for writing that first sentence, 2 for writing this second sentence. So by reading this and turning it into two fairly, to be honest, fairly straightforward equations just from reading them, you actually got 2 out of the 5 marks. The third mark comes for this part. So finding 8s plus and then 24s equals £46.08. Or if you, like I said, tried to make it all into k's, so that would have given you 4k plus 12k equals £46.08. And then you've got 16k equals £46.08. And then divide by 16 both sides to give you k equals £2.88. So if you did it that way, that's what you would have got. The third mark was for getting either this over here or this over here. The fourth mark was for getting 32s equals £46.08, or for getting 16k equals £46.08. And the final mark, 5, you had to find out k. So even if you went through my method here, got s, that wouldn't be enough. It's looking for k, which is the knife, which is £2.88. That's how you get all 5 marks. Looking at question 21, so we've got the diagram shows an empty container of height 21 centimeters. The container consists of a cylinder on a frustum of a cone. So the frustum of a cone here and the cylinder on top. Water is added to the container at a constant rate for 11 seconds. The sketch graph shows the depth of water as the container fills. The graph is a curve for the first 6 seconds and then a straight line for the next 5 seconds. Circle the height of the cylinder. So if we imagine pouring water into this container here, it's a curve because as it's more narrow at the bottom, you'd expect it to be filling up quite quickly, but then it gets slower and slower in terms of depth as time goes on, so you'd expect this to be curved. However, when it's a cylinder, it's going to be, as the diameter of the cylinder is going to stay the same by the nature of it being a cylinder, it's actually going to go up at a constant rate, hence why you have a straight line after 6 to 11 seconds. So if you want to find out the height of the cylinder, well, the height of the cylinder, if it fills up at the top and starts increasing at the same rate at this point here, so at the bottom of the cylinder, then the height of the cylinder is just the same as the length of our straight line in terms of height. So the depth, as it's moving in a straight line from 13 centimeters to 21 centimeters, it's going to be 8. So for this portion of our graph, it's a straight line, meaning that the depth is increasing at a constant rate. Therefore, the width of our cylinder or shape must be the same from the bottom to the top of the cylinder. Work out the rate of increase of the depth of water between 6 seconds and 11 seconds. So if we want the rate of increase, then you may have thought about this before when you're talking about the rate of change of, for example, a straight line graph. So if we had y and x there, when we say the rate of change, that means gradient. Okay, the gradient, which is just the change in y divided by the change in x. So in terms of between 6 and 11 seconds, we want to know what is our change in y and what is our change in x. So our change in y and our change in x. Our change in y is going to be 8. Our change in x is 5. We get that, and if it's 3 marks, you want to be showing the change in y and the change in x. So you may have seen the gradient formula y2 minus y1 over x2 minus x1. But for this, we're just going to say the change in y, which is 21 minus 13, so going from this height here to this height here, divided by the change in x, which is 11 to 6. So as we were picking this as our 21, that means we've got to choose 11 to be our first number here, which is going to give you, like we said before, 8 over 5. 8 divided by 5 or 1.6. State the units. Well, as we're talking about centimeters here and seconds, it makes sense that it's going to be centimeters per second. You could have put centimeters per second -1, that would have been absolutely fine as well. But the units are going to be worth 1 mark. So the top tip I guess I can give for this is, if you aren't sure about anything with the numbers, then you can actually just pick up a mark by stating the units. So you could just say, well, I know it's centimeters and seconds, so hazard a guess that it's going to be centimeters per second. That's worth 1 mark, irrelevant of your number work. So that's 1 mark. The second mark was for 8/5 or 1.6, and the third mark was actually showing how you got that 8 and how you got that 5, so doing 21 minus 13 over 11 minus 6. Question 22 is looking at a histogram. So with our frequency density and our time, let's give one reason why this is misleading. So you may notice that you've got this at the bottom here. So you could talk about it being and that's not a P, that's a B, a broken axis. Right here, we've broken up the axis. That means it's misleading, because we've said, well, these jumps are all 0.5, but this one we're going to say is 1.5. So you've broken up the axis, which may lead to the graph actually looking a bit misleading. That's where your 1 mark is. You could have also said things like the scale is not continuous from 0. That would have also kind of been talking about the same thing, but that's worth your 1 mark. So broken axis or scale is not continuous from 0. For B, we are looking at another histogram showing times taken to complete another task. Frequency density, time, seconds. Estimate the percentage of people who took less than 30 seconds. So 30 seconds is over here. We want to know how many people were less than 30 seconds. And with frequency densities, it's worth trying to just remember how we might have got frequency density. FD, frequency density, is going to be the class width which is so question 22, we're looking at a histogram, and we've got the time taken to complete another task, frequency density over here, time down here, and we've got to estimate the percentage of people who took less than 30 seconds. So it's worth remembering what our frequency density formula is. So frequency density, FD, is going to be our frequency, so the number of people that took in between this time, divided by the class width. And remember, when we say class width, we're talking about this distance here. So our first class is this group. Okay, so another way of really thinking about a class is to think of it as a group. So our group width or class width here is 10. So our frequency density, which was 40, is the frequency, which we don't know yet, divided by the class width, which we do know, which is 10. So how would we find the frequency, so how many people are in here, is by multiplication. We get rid of a fraction by multiplying by what's on the denominator, so what's on the bottom. So if we multiply both sides by 10, we're going to get 400 is our frequency. If something's divided by 10 and you times it by 10, you're left with what's on the top. So that's why this works very nicely. 400 is our frequency for this group here, or class. So let's just write 400 there. And what we're going to do, and I'm going to leave that formula up, is we're going to work out the frequency for the rest of them as well. So if we work out what the frequency is for this group, which will be frequency is frequency density multiplied by class width. Our class width is 10, our frequency density is 25, so 25 times 10 give us 250. For this, we've got frequency is class width, which is 20 multiplied by 20, so there's 400 people here. And this group here is going to be 5 times 10, which is 50. Okay, so if we want to work out the number of people, or estimate the number of people who were took less than 30 seconds, what we could do is actually say, well, if this is 400, then they are likely to be split evenly into these 4 intervals. Okay, so we want less than 30 seconds, so we take this 400 and we say, what is 1/4 of it? And that will be 400 divided by 4 times by 1, which will be 100. So there's 100 people that were less than 30 seconds. So in total, how many people were less than 30 seconds is going to be 400 from here, 250 from here, 100 from here, and we're going to add them together. That will give you 750. If we want it as a percentage, though, of this amount, then we're going to need to know how many people there are in total. So if we add all these together, we're going to get 1,100. So we're adding 400 to 250 to 400 to 50. That gives us a total of 1,100. However, we want to know what percentage of people is 750, because they are the ones who were took less than 30 seconds. Okay. So they took less than 30 seconds. So it's greater than x being these people. So that's going to be 750 out of 1,100. And then as a percentage, so times that by 100, and that will give you about 68%. So 68% is what we get when we multiply 750 over 1,100 by 100. So just to quickly recap, we find out by knowing that frequency density is frequency over class width. We can find out the frequency by multiplying both sides by class width. So frequency is frequency density times by class width. With that, we can find out all of these frequencies. If we add them all together, that will give us the total. And if we want to know the percentage of people who took less than 30 seconds, we find out how many people are in this side of 30 seconds, 1/4 of this amount plus these two. And it's that out of 1,100 times by 100 to get in percentage. Where the marks are here, if you manage to work out any of these, you get 1 mark. If you added all of these together to get 1,100, that's your second mark. Your third mark is for working out 750 and then attempting to divide it by 1,100. Even if your 750 was wrong or your 1,100 was wrong, if it's clear that that's what you tried to do, that's your third mark. Your fourth mark is for correctly getting that times by 100, and your fifth mark is for getting the percentage correct, so 68. Question 23 now is looking at a rectangle split into 3 triangles. So you see this big rectangle here, and it's split into these, one shaded in here, one unshaded, and one other shaded in here. The total shaded area is 7.5 centimeters squared. Work out the value of x. So what we're going to have to do here is remember that the area of a triangle, when we've got the perpendicular height, so our perpendicular height being 2x here, to the base being 3x plus 1, we can do the triangle being base times height and then divided by 2. So we do this base as an expression multiplied by 2x, that will give us part of it, and then we divide it by 2, that will give us the area of the whole triangle, sorry, the whole rectangle. Once we've got, no, it is the triangle, sorry, that will give us the area of the whole triangle. if you've got that, then work out the area of the rectangle. So the area of the whole rectangle here. If you want the total shaded area, then the shaded area is going to be the area of the rectangle subtract the area of the triangle. So if I take this out, that'll leave me with this area here and this area here. So it's a subtraction. It's, if you want to visualize it over here, it's like area of the whole rectangle subtract the area of the triangle. That'll leave you with this weird kind of double triangle over here. So triangle 1, triangle 2. So let's see what that would look like. If we work out, first of all, the rectangle, kind of makes sense to me, I guess, to see this is working out the area of the rectangle first of all. The area of the rectangle would be base times height, and the base is 3x plus 1, and the height is 2x. I guess because you're probably more comfortable seeing it like this, I'll write it like this, just for simplicity. 2x and then open brackets 3x plus 1. So we expand those brackets, and that will give us 2x times 3x, which would be 2 times 3, which is 6, x times x, which is x squared, and then 2x times positive 1, so 1 times 2x, which is just 2x. That's the area of our rectangle. Over here, let's do the triangle. Base is 3x plus 1, height is 2x, so we're actually going to get the same thing. We're just going to times base times height, which is the same base and same height. So we'll end up with 6x squared plus 2x. But remember, it's all divided by 2. So it's all over 2. So what we've got to do is half our 6 and half our 2. So it's going to end up being 3x squared plus x. Right. So as we've got the area of that triangle and the area of the whole rectangle, what we can do now is subtract. So we know that the area of this missing bit here is going to be 6x squared plus 2x, so the area of the rectangle, subtract 3x squared plus x. And we know that that equals 7.5 centimeters squared, so 7.5. So 6x squared minus 3x squared gives us 3x squared. 2x minus a positive x will give us just x. Remember, this is 2, take away 1. The big mistake here is that people, I guess, don't really see it as a subtract. They might see it as maybe adding another x, and so the biggest mistake I've seen is people saying that this is 3x. Notice that this is actually exactly the same as what we got when we found the area of this triangle, because the area of this triangle is going to be half the area of the rectangle. So therefore, as it's half the area of the whole rectangle, the rest of it must be the remaining 50%. So as this was 50%, that means, so this being the triangle here, that means that this one, so triangle, I think I called this one triangle 1 and triangle 2, them added together as well, must also be 50% to make up the whole area. Anyway, so you could have done all that and ended up with 3x squared plus x, and that equals 7.5. We hopefully by now will be used to seeing these kind of problems as a quadratic equation. So we've actually got a quadratic equation here. We've got 3x squared plus x equals 7.5. What we're going to do, so I'm just going to get rid of some of this stuff because we might need some space, is try and turn it into a quadratic equation. What we can do is try and solve it, because when we solve it, we'll find the value of x. So to start off with, it might be easier if you make it equal to 0. So to make it equal to 0, we're going to subtract 7.5 from both sides. 3x squared plus x minus 7.5 equals 0. And we got that by subtracting 7.5 on this side to make it equal 0. 7.5 minus 7.5, 0. and then subtracting 7.5 from this side, which gave us minus 7.5 here. So just for the sake of space, I'm going to write the rest of it up here. So 3x squared plus x minus 7.5. This is an awkward decimal. Let's just times it by 10. And when I say times it by 10, I mean times everything by 10. Okay, so we're multiplying 3x squared by 10 to make it 30x squared. We're timesing x by 10 to make it 10x. And we're multiplying minus 7.5 by 10 to make it minus 75. As well as multiplying 0 by 10 to keep it at 0. Once we've got that, you can hopefully see that this factorizes. But before we're going to factorize it, we could simplify it. These are all divisible by 5. So let's divide them all by 5, as is 0. So we're not going to get into that now. 0 divided by 5 is even infinity, but anyway. 30x squared divided by 5 is going to be 6x squared. 10x divided by 5 is going to be 2x. And minus 75 divided by 5 is going to give us 15. 0 divided by 5 is going to be 0 for the sake of argument. Just going to keep that as a squared up here so we don't get confused. Okay, now hopefully it's easier to see that we can try and factorize this. How we would try and factorize this: 6 times 6 times 15, which would give us 80. So numbers that multiply together to make 80 but add together to make 2, we're going to notice that it won't factorize because there are no numbers that multiply together to make 20 but add together to make 2, and therefore what we're going to try and do instead is use the quadratic formula. So instead of trying to factorize it, which it doesn't do, remember minus b plus or minus the square root of b squared minus 4ac over 2a. When we've got a quadratic equation in the form 6x squared plus 2x minus 15, the coefficient of x squared here is a, the coefficient of x here is b, and the constant term is c. So substitute these values into here, and that will give you your answer. What it will also give you, though, is another value, which is not your answer. And we know it's not your answer because it will come out as negative, and you can't have a negative length. If this is 2 lots of x, and we end up getting x as minus, say, 3, then 2 times minus 3 is minus 6, and we're not going to get any negative lengths. So our positive length that comes out of using this equation is going to be our answer for x. So to put them into the quadratic equation, again, let's just make a little bit of space. Minus b plus or minus the square root of b squared, minus 4ac is going to be minus 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 15 times 6. So sorry if I've confused you there, I've just mixed my C and A, so I've just swapped them around because emphasis on the fact that it doesn't matter in multiplication which number you put first. Over 2A, and A is 6, so 2 times 6 is going to be 12. Okay, once you've simplified this, so we've got 4 times 15, which will be 60, 60 times 6, which is going to be 360. You can actually say, so it's going to be, I've just wiped out the quadratic equation, so it's minus b plus or minus the square root of b squared minus 4ac, 4o all over 2a. So it's going to be minus 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 6 times minus 15, all divided by 2a, and if a is 6, then 2a is going to be 12. So 4 times negative 15 is going to be 60, and 60 times 6 is going to be 360. But as this was all a negative, because we got one negative in the multiplication, that's going to be minus 360. So 4 minus 360 is going to be the square root of 364, all divided by 12. And yes, you could have just typed that into your calculator, but I've simplified it here. And you'll find that your answer will be equals. So if you do it first of all with a plus square root of 364 and then with a negative square root of 664, you get two answers. And like I said before, the only answer which makes sense is the answer with a positive value of x, because we're talking about length here. So that's going to give us 1.423 to one decimal place, 1.4. Okay, so x is 1.4 to one decimal place. Let's just get rid of some of this stuff so I can hopefully make it a little bit more clear where the marks are. So we've already done all that. So we've tried all that stuff, and that's how far we got. Okay, so 1.4 is our answer. The breakdown of the marks though. Your first mark is over here, so it's 5 marks. The first one is over here for getting your quadratic formula equation, but only after getting your area of the triangle. So once you found out that it was, once you found whatever the area of the triangle was, that was your first mark. Your second mark, was down here for getting your 3x squared plus x minus 7.5. So that's your second mark. Your third mark is for your attempt to put your a, b, and c into the quadratic equation. So actually, you don't get many marks until you start using the quadratic equation. So when you've put your digits into the quadratic equation, that's your third mark. If you got 1.423, that would have been your fourth mark, and your fifth mark is over here for getting 1.4. So your fourth mark, let's just explain a little bit more. You could have simplified your quadratic equation, and that would have actually effectively given you the fourth mark, even if you didn't put 1.423. The final mark is for the answer. So that's 1 mark for doing the, it was 6x squared minus, 6x squared plus 2x, and then dividing that by 2. That gave you your first mark. Okay, so 3x squared plus x gave you your first mark, as long as you said that equals 7.5. Okay, first mark. Second mark, over here, quadratic equation, putting it into that. Third mark, putting into the quadratic formula, and the fourth mark for attempting to simplify the quadratic formula or getting 1.423, and the fifth mark was for 1.4, your answer. Question 24 is a tetrahedron problem where we've got a 3D diagram representing a paperweight. The horizontal base ABC is a right angle triangle. C to T is vertical. Angle ACB, so A to C to B, is 36 degrees. Length BC is 13.3, and length CT is 9.6 centimeters. So we've got to work out the angle, so the size of the angle between AT and the horizontal base, i.e., if you can try and visualize it, it's this angle here. So AT and the horizontal base. So first of all, we've got to think about what we might be able to do with our right angle triangle down here at the bottom. And we're given this angle here, we're given this length. If we're trying to find out this angle here, then finding out what AC is going to be useful. So vision our triangle here at the bottom. and I'm trying to re-sketch that there, so that's C, B, and A, or as it says here, ACB. We've got a right angle there, we've got 36 degrees here, and then 13.3 here. So if we're looking for this length here, but we've got this angle here, then we need to think of it from this angle's point of view. So from this angle's point of view, we have the hypotenuse, and we have the adjacent side that we're looking for. So A to C is the adjacent side, but we've got this angle. So from cos of 36, and remembering SOHCAHTOA, as we're looking for, we're using cos, because relative to this angle here, we've got the adjacent that we're looking for, so A, and the hypotenuse that we've got, which is 13.3. So cos 36 is the adjacent over hypotenuse, so we don't know what the adjacent is over the hypotenuse, which is 13.3. So to find out what A is, we've got another fraction here, so we multiply both sides. To get rid of that fraction, we multiply both sides by 13.3. So if we type into our calculator 13.3 cos 36, that will give us A. Okay, so from there we just multiply both sides by 13.3, and if we plug that into a calculator, you'll find out that A is 10.76 to 2 decimal places. So 10.76 to 2 decimal places. Now we've got that, we can work out what this angle is. If I was to draw the triangle CTA, so I'm trying to draw it in the same manner at which it is drawn here, so I'm trying to draw that triangle there. This is 10.76, it's a right angle triangle, and this length here is 9.6. If we're trying to find out what this angle is here, so this angle there is that angle there, so we're trying to find out what this angle is here, well, whatever this angle is, which we'll call theta, this length here, let's do it in a different colour, this length here, if we're talking about this angle, this is the opposite, and if we're talking about this angle here, this is the adjacent, because remember, opposite the right angle is the hypotenuse. So we've got the opposite and we've got the adjacent. So that tells me we'll use tan. Tan of the angle is opposite over adjacent. So tan theta is 9.6 over 10.76. As we're looking for an angle, remember we have to press Shift tan, so press Shift in your calculator screen there, up here, Shift, then tan. That should get you tan to the -1, and then you press 9.6 over 10.76, close the bracket, equals, and then it will give you 41.7 degrees. So your answer, 41.7 degrees. The marks for this one gives you 4. The first mark is for setting up this, so cos adjacent over hypotenuse, but substituting them in. The second mark is for finding 10.76. The third mark is for the correct use of tan here, so tan, and then if you didn't get 10.76, but whatever you got here, you put that there, as long as it's 9.6 over that, that's your third mark, so 1, 2, 3, and your final mark was for getting 41.7 degrees. Okay, so this was SOHCAHTOA, but it used a couple of these. As we're getting towards the end of the paper, you would be expected to maybe use a couple of different elements of your trigonometry, so cos and tan in this example. Question 25 now, the final question on the paper. The number of bacteria n after t hours of an experiment is given by the formula here. N equals a times 2 to the power of t over 4, where a is a constant. At the start of the experiment, there are 250 bacteria. Show that a equals 250. So we would show that a is 250 by putting in 250 equals a times 2 to the power of t over 4, right? That's right. So I'm just making a video. Question 25 on the paper, we're looking at the number of bacteria n after t hours of an experiment is given by the formula n equals a times 2 to the power of t over 4, where a is a constant. At the start of the experiment, there are 250 bacteria. Show that a equals 250. So if we're talking about the start of the experiment, then that means our t for time is 0. If we substitute 0 instead of our t up here, so 2 to the power of 0 over 4, which is 2 to the power of 0, because remember, if you divide 0 by 4, that's just going to be 0. And 2 to the power of 0 is 1. As remember, one of our indices rules was anything to the power of 0 is 1. So if it was x to the power of 0, still 1. Ay squared, that to the power of 0, would still just be 1. As it's 2 to the power of 0 equals 1, that means n equals a times 1. And if n is 250, then a must be 250. The mark scheme gives you the answer mark for 2 to the power of 0 equals 1, and that's what you just need to show an understanding of for that one mark. 25b, how long is it before the number of bacteria doubles? So what we're saying here is we're using this formula. N equals a times 2 to the power of t over 4, and if the number of bacteria doubles, then whatever n was, it's now twice the amount. So you'd get 2 equals 2 t over 4. I'll just rewrite that so it's a little bit more obvious with our power. So 2 equals 2 to the power of t over 4. We want to work out how long it is before the number of bacteria doubles. So that means that, yes, 2 equals 2 to the power of t over 4. T over 4 must equal 1, because 2 to the power of 1 is 2. Okay, because we must kind of show the examiner an understanding of 2 equals 2 to the power of 1. Therefore, we're replacing that 1 with 1 is t over 4. As t over 4 equals 1, we can solve that equation by multiplying by the denominator. So t equals, and then 1 times 4 is 4, so therefore it's going to take 4 hours. Mark scheme will give you 1 mark for showing that 2 equals 2 to the power of t over 4, and then the final mark for getting the answer of t over 4 equals 1, and then therefore t equals 4 hours. Final part of the paper is Megan's question about working out that there are more than 1 million bacteria after 2 days. Is she correct? Well, if she's correct, then t, which is, remember over here it says hours, so after 2 days that would be 2 times 24, so 48 hours. So if she's correct, then 250, which we've worked out to be a, 250 instead of equals 250 multiplied by 2 to the power of, and instead of t now it's 48, so 48 over 4. What would that be? 48 over 4, so 250 times 2 to the power of 12. Type that into your calculator and you're going to find 1020 24,000. So 1,024,000. That is now n, which remember is the number of bacteria, so she is right. So the answer is yes, and you need 1,024,000. 1 mark, again, because this is just a 2-mark question, 1 mark is for working out that that's 48, but then you also need to substitute it into this equation. So you need to rewrite your equation that you were given up here with your new t value, which you found out to be 2 times 24, so 48. And the final mark is for both 1,024,000 and yes. So as it's the last question in the paper, you do need to put both of those things to get the final mark.